Hello, Pips. Welcome to another session of Azure Zero to Hero Microsoft Learn community. This is Saidal together with Mohsen Akhavan, the other community leader. We are here another Saturday and we have another guest who is going to amaze us by the content that he's going to share with us. So if you haven't joined us yet in Microsoft Learn, please use that QR code and also aka.ms/join02hero and be part of our big community. We almost more than 2,500 together to learn more about Microsoft and all things that we would love to hear about Microsoft and Microsoft Learn. So let's go with our slides. So if you if you are part of Microsoft Learn right now, it's perfect. But if you haven't joined us yet, please follow these links. Microsoft Learn is the richest place that you can learn and share your knowledge with rest of people in around the globe. And also you can be part of a big community full of experts and people that would like to share different things regarding Microsoft and Microsoft technologies together with you. It's a big community and a hub tech community that you can learn a lot about different things like news and also like a conversation live session like that we have right now. And beside that, there are more communities and community and learning communities that you can join and be part of those communities too. Don't forget to join Microsoft Learn Cloud Skill Challenge, which is related to AI. It's like 30 days. And if you pass all of those challenges, you will be able to get a discount about for the Microsoft exam fundamentals. And also it's a big chance for you to learn about Microsoft Learn together with the rest of experts. And also we have a code of conduct. So we would like and expect from you to be aware of others, be friendly, be welcome. And also if you ask your questions, please make sure that you are be part of the guidance that we are following in the Microsoft Learn different communities. So today we have a special guest here. I'm going to add Dennis Torres to our stage. So Dennis is DBA and former data platform MVP living in Malta, who loves SQL Server and software development and has more than 20 years of experience. He moved to Malta after more than 10 years leading the SQL Pass chapter in Rio de Janeiro, and now is a member of leadership team of MMT PUG Pass chapter in Malta, organizing meetings, events, and webcasts about SQL Server. He is an MCT, MCSC in data platform and BI with more titles in software development. He can be found working for DTower software and speaking in SQL Saturday around Europe. Very welcome, Dennis. Thank you for joining us today. We cannot hear you, Dennis. Let me see. I think you're muted.
Yeah.
Okay.
Thank you very much.
Perfect.
Nice to meet you, everyone. So let me share my screen.
Yes, please. And the stage is yours, man.
I share the screen, but the sharing is on Backstage. It needs to be put live.
Let me check. Let me stop my sharing screen. You can try it again now.
I don't have option for that. I think if I share the screen again, it will go to the Backstage. Yes, you need to promote from the Backstage.
Yeah. That should be fine now.
Yes,
okay,
now it's
good. Man. Thank you.
Okay. So let's start. Today I'll be talking about SQL Server in the cloud, the available options for using SQL Server in the cloud. This is a great session for who is thinking about migrate from on-premise to the cloud. But even for the ones who are already using SQL Server in the cloud, I'm sure this session will have some surprises. Of course, it's impossible to talk about all the point of views existing on this subject. So this session is be filled with links to additional information. So at some point, you may would like to capture these links that I show during the session. So this is me. Thank you for the introduction already made. I'm a former data platform MVP, trainer, leader of the Malta Data Platform User Group. But on the side of the screen, you see my contacts. It will be a pleasure to stay in touch on social media. I'm very active, especially on LinkedIn and YouTube, but it will be a pleasure to stay in touch, send me an emails with any questions and so on. So the agenda today, I made a list of the agenda, but I'll not get into details on here. Let's go step by step. First, we'll talk about pizza as a service. Imagine that you want to take a pizza. There are many different ways to take a pizza. One of the possible ways to take a pizza is to make the pizza at home. The blue items are everything that you need to provide. And you see, when you are working on premise, it means you are making the pizza at home. You need to provide absolutely everything. Absolutely everything and build absolutely everything. You are responsible for everything. But there are other options. Another option, we can go to a market and get a pre-made pizza. In this case, buying a pre-made pizza, the green items are already provided for you. You don't need to care about them. You need to care only with the blue items. So you are reducing the amount of items you need to care about. A third option would be to ask a delivery. Ask a delivery to deliver a pizza for you. In this case, the pizza will be delivered. You need to take care of the blue items, the drinks and the dining table, but all the rest is responsibility of who will provide the pizza for you. And finally, there is an option to dinner out. In this case, everything will be provided for you. Why I'm talking about pizza? Why I'm talking about pizza in a session about cloud? Because we're talking about the different levels of services that which we have in the cloud. We can be working on-premise, totally on-premise. In this case, we are not using the cloud. We can use the infrastructure as a service. In this case, the cloud provides some infrastructure, but we need to provide the rest. We can use what is called platform as a service. In this case, the cloud provides a platform that gives us a service almost ready to consumption. Yes, Darcy mentioned there are pineapples on SQL Server. Yeah, SQL is delicious, right? And the last level is the software as a service. Software as a service is the last level when you just use a software online, like Office 365, for example. So usually when using Azure SQL, we choose between infrastructure as a service or platform as a service, software as a service for very specific services. Okay, so this same example related to the cloud, with the items representing the cloud resources. On-premise, you manage everything. On infrastructure as a service, the cloud gives you some infrastructure, but you need to manage from the operating system and up. Platform as a service. In this case, you manage the data and the applications over the platform that is entirely given to you. And finally, software as a service, you just use the software provided online for you. About moving to the cloud, I like a lot this Dilbert, this Dilbert story. Because it's very interesting and tells us a lot about moving to the cloud. The boss asked, I needed to know why moving our app to the cloud didn't automatically solve all our problems. Raise your hand who has a boss who believes in something like this, that just moving to the cloud will solve all their problems. And Gilbert replies, you wouldn't let me react at the app to be cloud native. So they got a non-premise app, move it to the cloud, and the app is not cloud native. So it didn't solve the problems the company has. They are just running an on-premise application on the cloud. Just put it in containers, and you can solve a problem just by saying techy things like Kubernetes, for example. The point is, the move to the cloud is not just to get what you haven't put online. The move to the cloud involves a transformation of your application, and many times involves a more careful way of thinking. Sometimes involves some care of the way of thinking that you are not used to when working on premise. On the process to move to the cloud, we consider to have two stages. One stage is called lift and shift, and usually the companies start on this stage, lift and shift. What it means? This means that they want to see the application running in the cloud in the same way that this application is running on premise. So in this case, they end up using infrastructure as a service. They build in the cloud the same infrastructure they have on premise and move the application to the cloud. They want to be in the cloud to say that they are in the cloud, but they don't want to have the entire work of modernizing the application yet. But as we just saw from Gilbert, uh, we will only get the entire advantage from the cloud if you pass by the app modernization. We need to make an app modernization, transform our app to be a cloud native app, and make use of the PaaS services and not only the IaaS services. In fact, the IaaS services are among the most expensive ones in the cloud. The PaaS services allows you to be flexible in relation to the amount that will be charged from you. While if you choose the IaaS, you are just leasing an infrastructure, and this will end up being a lot expensive. Then many people say, oh, the cloud is too expensive. Yes, because you made a wrong migration. You made a lift and shift and left it there. You need to go one step ahead. You need to make the app modernization to improve your applications, make them cloud native, and reduce the costs of your environment. There is an old joke that is used to say there is no cloud, it's just someone else's computer. It's an old joke. Many of you may have heard this joke before. It's interesting, but I don't like this joke. I don't like this joke. I would not use this joke at all. Because this joke gives the idea that the cloud is infrastructure as a service. We are just getting a computer from another person and using the computer from another person, from another provider in this case. No, that's not what's happening. When you go to dinner out and having a pizza in a restaurant, you are not only just using the oven of the restaurant, you are using the entire service of the restaurant. And the entire service of the restaurant which you are using is avoiding you a lot of concerns and troubles in relation of the pizza preparation. So you are not just using the oven of the restaurant. Saying that the cloud is just someone else's computer is the same as saying that when you go to a restaurant, you are just leasing their oven. That's not true. How do you choose a cloud provider? The point is, one important point to choose a cloud provider is, will your cloud provider help you on the app modernization and have the options you need for the app modernization? And will these options be easy to use to create cloud native applications? Or will your cloud provider end up keeping you stuck in infrastructure as a service format? That's a good point to choose the cloud provider that you need to use. So, now talking about options related to migration, let's start talking about infrastructure as a service, because the entire cloud migration starts with infrastructure as a service. And when we talk about infrastructure as a service, we are talking about virtual machines. We are talking about using virtual machines on the Azure environment. So let's talk about virtual machines. Is the target for lift and shift, as I just mentioned. And virtual machines use a resource called Bring Your Own License. When you provision a virtual machine on Azure, you have two options. You may be provisioning a virtual machine containing the SQL Server already. In this case, the virtual machine will be charging you the license of that SQL Server. The price that you pay for the virtual machine is include the price of the license of that SQL Server. But there is an option called Bring Your Own License. If you have on-premise license using software assurance, you can move your on-premise license to the cloud. When you create a virtual machine, a SQL Server virtual machine in the cloud, for example, it asks you, do you have the license for the software? Would you like to bring your on-premise license to the cloud? And it will involve about for checkboxes because in case of the SQL Server, it will ask you about the Windows license and it will ask you about the SQL Server license. So there is an interesting point in relation to moving your on-premise license to the cloud. And in this case, saving money with the virtual machines when making lift and shift. There are many templates for virtual machines. You can use these many possible templates of virtual machines, or you can create custom templates in your subscription. And this has become easier and easier to get a virtual machine that you completely customize and create a custom template from a virtual machine that you completely customize. So you have options to use a pre-built template or customize your template. Let's talk about virtual machine disks. We are talking about infrastructure as a service. But we should not think, oh, everything will be easy. I don't need to care about infrastructure. You don't need to execute things related to the infrastructure because Microsoft will take care about this for you. But you need to make the correct choices. You need to understand the options that you have in relation to the infrastructure and make the correct choices. For example, let's talk about disks. When we check the virtual machine options, we have many sizes of virtual machine, and the sizes make a combination of the vcores that the virtual machine has, amount of one available, data disks. When it says data disks, is the maximum data disks that the virtual machine support. It doesn't mean that in the moment that you are creating the virtual machine, it will get this data disk. It means that the virtual machine support up to this amount of data disks. Max IOPS, the virtual machine support. This is very important. Max IOPS, the virtual machine supported. Because you need to discover how many IOPS your application will need, how many IOPS your application will consume, and then decide the virtual machine you need to use. Every virtual machine has a temporary storage. The temporary storage is a place where, like the name says, it's temporary. You should not store anything important on the temporary storage because at any moment, if you deallocate, that's the name we use on Azure to forcibly turn off the virtual machine. At any moment, if you deallocate the virtual machine and allocate again, the virtual machine may be linked to a different temporary storage. So everything you had on the temporary storage may disappear. And then features supported, premium disk, if it premium disk is supported or not, and an estimation of the cost of monthly cost of this virtual machine. So there are many information important when we choose the size and SKUs of virtual machine. So in the portal, we only see the maximum VM IOPS without caching. This max IOPS is without consider caching of the data. Because the virtual machine will also consider caching of can also consider caching of the data, and this information doesn't immediately appear in the portal, not in the portal. We may need the size definition to check the VM IOPS with cache and with another feature called disk bursting, which I will be talking about. We need to avoid IOPS capping from disk and from the VM. When we build a VM for a specific purpose, especially for a database server, you should avoid to reach IOPS capping either from the disk, either from the VM. If you reach a situation of IOPS capping, you are throwing the money of your company in the garbage. You are really throwing the money of your company in the garbage. On the documentation, you may find additional information about the IOPS of the virtual machine, like IOPS with cache, with burst, uncached, and so on. So sometimes on the documentation you find some additional information. And let's talk about disk capping. This image is describing a situation of disk capping. What's the point? We saw on the image before that the virtual machine has a maximum IOPS. Yes, the virtual machine has a maximum amount of IOPS. But the disks also have, each disk also has a maximum amount of IOPS that disk supports. So let's say that I created a virtual machine standard D8S underscore V3. This is the virtual machine I created. And I put 3 disks, which are E13 30 disks. Then my application is trying to get 10,000 IOPS from this virtual machine. What will happen? The virtual machine will break down the requests according to where the data is located, of course, but can break down the request between the disks and get 4,500 IOPS from one disk, 4,500 IOPS from another disk, and 1,000 IOPS from the third disk. The problem is this disk E30 doesn't support this amount of IOPS. The maximum IOPS this disk support is 500 IOPS. So doesn't mind how many IOPS the VM will request. The disk will answer with the maximum IOPS it supports. So each disk will return 500 IOPS, and the application which requested 10,000 IOPS will receive 1,500 IOPS because you made the wrong choice of combination between disk and virtual machine. And between disk and virtual machine, with a bad combination, you are suffering what is called disk capping. The resources of the disk are capping the amount of IOPS available for you. But let's talk about a second situation, which is called VM capping. The disks have the IOPS limitation, but the VM also has the IOPS limitation of the VM. So it doesn't care if the disk supports a certain amount of IOPS, because the VM has its limitation as well. So let's consider that I'm using the same virtual machine, but now I'm using the disks P30. The P30 disks support 5,000 IOPS each disk. So 3 disks, each one supporting 5,000 IOPS. I have a total of 15,000 IOPS. This, in a simple calculation, would be enough for the application. But again, you are throwing your company money away. Why? Because you chose the wrong VM for these disks. This VM has a maximum limitation of 12,800 IOPS. It will not go beyond 12,800 IOPS. So all the disks will be working under their maximum capacity because the VM will be capping their capacity. And the application, which is requesting 50,000 IOPS, will be receiving only 12,800 IOPS because, again, you made a bad combination between virtual machine and disks. So, uh, many of you, I would love to hear your comments. Many of you may have thought that, oh, it is easy to create a virtual machine. It's just to choose a model and that's it. You need to know what you are choosing. You need to understand what you are choosing, or you end up in a situation that you are underusing resources uh, and receiving some capping on the VM or the disk and throwing the company money away. Disk and VM bursting. I mentioned that I would explain later the disk and VM bursting. Bursting allows a VM and disk to go beyond their IOPS for a limited time. For a limited period of time, they can go above the limitation of their IOPS, either for the VM, either for the disks. So disk bursting and VM bursting can be independently enabled. So you may have enabled disk bursting but not VM bursting. You may have enabled VM bursting but not disk bursting, or you may have enabled both. And one question, from you who have VMs deployed on Azure, do you know if the VM and the disks which you deployed support bursting? Because only some VMs and some disks support bursting. Only some, not all. There is one kind of bursting which is called credit bursting, can be used with premium disks or standard SSD disks, SSD disks. HD disks don't work, hard drives don't work with bursting. From 512 gigabytes. So the disk needs to be SSD to work with bursting. And there is a on-demand bursting. On-demand bursting is specific situations when your applications request bustings on the demand. This can be used on premium SSD disks. Only premium SSD disks support this on-demand bursting. What is the credit bursting? Well, we talked about capping. We talked about capping and how if your applications request something that is above the limits of the disks or the virtual machines, you will be receiving capping on the disks or the VMs. But what if is the opposite? What if your applications are under requesting and requesting less than the capacity of the disks and the VM? In this case, if the disks or the VM or both support bursting, the unused IOs will be stored in what is called a bursting bucket. So you have unused IOs. You had that capacity and your application didn't use that capacity. So in some moments of heavy usage, when your application is really under heavy usage, you can go on the bursting bucket. When I say you can go, it's automatic. The set of your VM and disks will go to the bursting bucket and use this reserve that you have in relation to IOPS. So if in some moments your application is underusing the amount of IOPS available, the amount underused will be stored on the bus bucket for some emergencies when the application needs to overuse the amount of bursting, the amount of IOPS. But consider this, the same explanation applies to the disk and applies to the virtual machine. So you have a combination there, a combination of bursting between disk and virtual machine. You may have a situation where one is supporting bursting and the other is not. And you need to take care about that. You need to know what exactly you are provisioning on the Azure environment. So this list may not be updated. This list is a bit old, may not be updated, but this is a list of virtual machine series which support busting. Virtual machine series that support busting. And you can strip in disks for maximum throughput. Sometimes join the amount of IOPS that you need with the amount of space that you need may be a bit difficult. Why? Because if you need a huge amount of IOPS, then if you go to a single data disk, that disk will be huge as well. According, you need a high amount of IOPS, the space on the disk will be huge as well. So what can you do to work around this? You could use smaller disks, but many smaller disks on the virtual machine. Remind that we talked on the list about the amount of disks that the virtual machine support. How many data disks you can put on that virtual machine? So you can put multiple data disks which have smaller IOPS capacity, but joining this smaller IOPS capacity, they reach the amount of IOPS that you need. And the smaller disks will have a smaller space and may fit the space that you need. So to reach a combination of IOPS and the space, you may need to use disk stripping on a resource called storage space on the Windows operating system. And since these disks are managed disks, there is already a redundancy provided. So you don't need to make disk stripping with redundancy at the operating system level because there is already redundancy on the physical level. So this allows for your volumes to have the sum of IOPS and data size. You reach the combination of the sum of IOPS and data size which you need. That's how you can reach this combination. So you may have thought, oh, I'll never care about infrastructure details again. If you decide to work with infrastructure as a service, you will not be the one who implements, but you need to understand the options available to choose the correct combinations. So it's a shift on our knowledge when we go to the cloud. We need to understand the available options. The disks available are linked also to the TempDB configuration. We are talking about Azure SQL. Azure SQL uses TempDB for many internal operations. This is a critical database on Azure SQL, the TempDB. And the I/O performance of the TempDB is critical as well. So we need to use the lowest latency storage possible to ensure that the TempDB has the best performance possible. What's the lowest latency storage possible? Well, our data disks which we link with our virtual machine, they are managed disks located in external storage linked to the hardware of our virtual machine. But the temp disk is a disk physically located on the virtual machine, which we put online. So, I'll mention about the TempDB and the temp disk in a moment, but the TempDB should have the same number of data files as server has CPU cores, up to 8. This is a SQL Server rule, but SQL Server 2022 changed about this rule. This rule is not so important to SQL Server 2022 as it was to previous versions. If you check about TempDB new features in SQL Server 2022 in the cloud, you'll find this kind of information. The data file should all be the same size and have the same outgrowth settings. This is very important, but then how much you need to be concerned about this is something which depends on the SQL Server version that you are using. If you are using an old SQL Server version, you may need to manage the size and the outgrowth setting manually, while the new SQL Server versions will manage these features for you. Except if you are using a new SQL Server version, but using SQL Server compatibility level with older SQL Server versions. In this case, you still need to use old methods for the database which are using old compatibility levels. And finally, I started talking about this, and it was the last item here. In Azure, the best practice related to the TempDB is to put the TempDB on the temp disk. You can redirect the TempDB for the TempDB to be stored on the temp disk of the virtual machine, because it's the one which will provide the lowest latency on the access to the disk. VM and security. Let's talk about virtual machine and security. SQL Server 2022 supports Azure authentication. This means that you can use Azure IDs to authenticate to SQL Server 2022. And virtual machines can be integrated with Azure authentication. So, start, put some more work on the building of your virtual machines and configure your virtual machines to be integrated with the Azure authentication. You should not keep creating virtual machines and just put an administrator password for each virtual machine and that's it. No. Integrate the virtual machine with Azure authentication, and then you log in on your virtual machines using your Azure ID, your Azure account. And this is supported for SQL Server 2022 as well. If you are using older version, This is not supported on older versions of SQL Server. The virtual machine support, but the SQL Server doesn't. So, what I will show about virtual machines. We talked a lot about disk bursting. We talk a lot about disk bursting, disk capping, VM capping, and so on. So the point is, how do I find the correct combination of disk and VM which I should use? The point is, in the portal is not easy. And many times the correct combination is not one of the possible templates. The correct combination may not be on one of the possible templates. This is an example of a PowerShell statement which lists the features of virtual machines and it's filtering according to the features I'm looking for. I want virtual machines that support accelerated networking. I want virtual machines that have one specific amount of uncached disk IOPS, one specific number of CPUs, memory. So in this way, I can locate the virtual machines which support the resources which I want. I passed here. Yeah, this UI is terrible. I present it and wait. While we are waiting, we can check, for example, that one of the filters which I'm using, let me locate, is related to the region. One of the filters I'm using is related to the region because not all types of virtual machine are available on all the regions. So you need to look on the correct region to find the virtual machines which will fit your needs. So using PowerShell on the Cloud Shell environment is a good method to find the virtual machine which fit your needs. So this is one point. But let's see an example of creating an Azure SQL virtual machine. Azure SQL. When I choose Azure SQL in general, Microsoft decided to put everything under Azure SQL. All the options that Azure SQL provides to me are under the generic name Azure SQL. So I have the SQL database options, the SQL managed instance options, and the SQL virtual machine options. So I can choose one image, for example, and see I have a specific image here, which may or may not fit my requirements. And then choose create. The image this shows was bringing a virtual machine which was a bit more expensive, requires an environment without paying limits. So if I choose the virtual machine, it should have solved the problem. Okay. So I changed the image that I was choosing. Then I have the choice of the virtual machine. See, the choice is more or less made for me. The choice is more or less being made for me. So many times, probably I would like to build a custom virtual machine. I would like to build a custom virtual machine and make my own configuration with the disks that I choose and so on. And here I have the question related to the hybrid benefit. Do you have a license? Let's say that yes, I have a license. At this moment, I'm confirming the Windows license. I'm confirming that I have the Windows license for this virtual machine. Oh, sorry, I end up getting the Windows data center. Okay. SQL Server license. And I need to confirm the license for the Windows virtual machine. We always put an administrator password because the configuration to integrate with Azure AD is done later. Is done on a later stage. So 0 VM test 0 VM group are not really correct. I just would like to show the disks, and the OS disk is the temp disk, which I mentioned that every virtual machine has. So we choose which kind of disk we would like to use. The temp disk related to the virtual machine. Then we have the networking options. Manage options. Monitoring. Advanced. I want to reach the SQL Server settings. I will enable or disable SQL Server authentication. If I enable SQL Server authentication, I need to define a SQL Server user for that. Would I like to integrate with Key Vault? Make an integration between SQL Server and Key Vault? That's a possibility. The SQL connection on inside the VM, inside the virtual network, or public to the internet. I choose. And this can be changed later. And the storage. See? The temp DB will be stored by default using the local SSD. So the pre-built image already bring this to me. And then 2 data disks will be brought with 5,000 IOPS each one to contain data and log. I chose the free SQL Server license, so it's not asking about the license, but I could, if I have chosen a paid license, I could say that I would bring the license from on-premise environment. That's an option. Bring the license from on-premise environment. So this is the configuration of a SQL Server virtual machine, how we start working and make the configuration of a SQL Server virtual machine and considerations about this process. If you have any questions, please just ask. I'm seeing the questions on the comments. So, now that we talked about virtual machine, let's talk about Azure SQL. Azure SQL, when I say Azure SQL, usually I don't count with the SQL virtual machine because SQL virtual machine is an IaaS service. But from many time ago, Microsoft put Azure SQL as a brand and consider Azure SQL Virtual Machine as part of this brand. So the only IaaS service under Azure SQL is the Azure SQL Virtual Machines. All the other services are PaaS services. Okay, let's talk more about the offers. Existing options. We have a PaaS offer, which is Azure SQL Database. In this case, we are talking about a single database, creating a single database. When we make the provisioning, it's not only the database which will be created, a SQL Server will be created, but all the charges are made on the database level. And one important point is that when we choose Azure SQL Database, we don't have access to instance level resources. We don't have access to use any instance level resources. So if your application on premise use any instance level resources from SQL Server, it doesn't fit on an Azure SQL database. So you have the option to change your application or to use infrastructure as a service and keep stuck on infrastructure as a service. These were your options in a distant past. But then Microsoft created a new PaaS service called SQL Server Managed Instances. SQL Server Managed Instance is designed for applications which need, for some specific business reason, they need access to the full instance of SQL Server. They need access to SQL Server jobs, cross-database queries, and many other resources that can only be provided for a full SQL Server instance. In this case, applications that have some specific requirement of a full SQL Server instance don't need to stay stuck on an infrastructure as a service. They can evolve to a PaaS to a SQL Server managed instance. Maybe in the future they can be rebuilt to use resources restricted to single database and use Azure SQL Database only. But until there, they can use SQL Server Managed Instance. And we have SQL Server Virtual Machines. In this case, it's not a PaaS service, it's an IaaS service which we use as a lift and shift when migrating to the cloud environment. When talking about provisioning an Azure SQL database, we need to talk about DTUs and vCores. DTU comes from database transaction units, while the vCores is the number of vCores on the machines. Okay, so what I'm talking about? I'm saying that when we provision an Azure SQL database, you choose if you provision your database based on DTUs or based on vCores. This is a choice that you made. DTUs is a unity created by Microsoft. Microsoft created this unity, it didn't exist before. We don't control physical resources. We don't specifically control how many vehicles we'll be using, how much of memory we'll be using, and so on. We don't have a detailed control related to this. And if we choose the DTUs, it doesn't charge licensing. You don't need the bring your own license. You don't need to move a license from on-premise to the cloud because the DTU model doesn't charge a license from you. And it's the cheaper option. It's the cheaper option. So it's the starting point that everyone should start, where everyone should start using DTUs. Why many people don't start there? Because the UI by default redirects you to vCores. It put vCores as the default option. And many people don't have the understanding about what are the DTUs. So end up choosing the vCores, which are way more expensive. Way more expensive. The vCores were created a lot of time after the DTUs because some Microsoft customers requested flexibility. They would like to have more flexibility in choosing how many vCores they would be using, how much of memory they would be using, and so on. They were requesting flexibility. So the vCore model was created exactly to provide this kind of hardware flexibility. And you can choose the hardware details when you choose the vCore model. It's more expensive than the DTU. Yes, it's more expensive than DTU and charge licensing. Why the DTU don't charge licensing and the vCore model charge licensing? Well, the main idea that you note is not explicitly written, but you note on Microsoft services is that if you start making some kind of reservation of hardware, if you want that hardware for you, then you pay the license of the software as well. If you allow Microsoft to control the allocation of the hardware for you, in this case, you don't pay the license of the software. That's the point. That's why on the DTUs, you don't pay the license of the software. On the vCores, it will charge license or you need to bring your license from on-premise to the cloud. DTU options. When you are using DTUs, we have the basic options, the standard options, and the premium option. The basic option has one single option to create a SQL database with 5 DTUs. This one single option has this latency time, 5 milliseconds, 10 milliseconds of latency, and it makes a backup potential of 7 days, and the database can have at most 2 gigabytes. The database can have at most 2 gigabytes. Why would you choose this option? Because this option costs more or less, depending on the region that you choose, depending on where you are, it costs more or less $5 a month. I bet you who are paying $200, $300 a month on a vCore SQL Server were not aware that you could have a DTU SQL Server for $5 a month. Yes, you can. It's the most basic DTU option. Then you have the standard option for the DTUs. The standard option, it goes from 10 to 3,000 DTUs. Under 100 DTUs, the maximum database size is 250 gigabytes. And up to 3,000 DTUs, the maximum database size is 1 terabyte. This is a big range of services. So this standard tier is classified as standard 0, standard 1, standard 2, standard 3. And why this classification is important? Because there are some SQL Server features that are only enabled after the standard 3. Some SQL Server features you cannot use below standard 3. For example, column store index you cannot use before standard 3. And the premium goes up to 4 terabytes. 4 terabytes of data. Up to 4,000 DTUs. Here you see the service tiers. Besides column store index, it also supports in-memory or LTP. You can also configure in-memory or LTP if you choose the premium layer for a DTU provisioning. And the vCore. The vCore itself linked to the number of vCores that you choose. And the number of vCores that you choose will be linked to the amount of space available to your database. So, up to 5 vCores, 1 terabyte, 10, 1.5, 23, then from 24 to 80 vCores, you can have a database up to 4 terabytes of size. But you need to be paying for a machine that have at least 24 vCores to support a database of 4 terabytes of size. A database for 4 terabytes of size is not a small database, it's not something small. Considerations for the migration. You should calculate the DTUs you need. There is a site called DTU Calculator that allows you to calculate the DTUs you need. If you are migrating from on-premise to the cloud, you can use the performance monitor on the Windows environment to capture some meshes of your SQL Server machines on on-premise environment and upload these meshes to the DTU calculator, and it will tell you how many DTUs you need to use. Consider if your application doesn't depend on any instance level feature. If your application depends on instance level feature, then you can't migrate to a SQL database. You need to migrate at least to a managed instance or change your application. These are two options that you have. If your database is too big, you need to consider other solutions. Mind that there is a maximum size on Azure SQL. On Azure SQL database, there is a maximum size of 4 gigabytes. To go beyond 4 gigabytes, you should consider other solutions. I'll talk about them. But the main point is, first of all, sorry. I was I explained it wrong. It's not 4 gigabytes, it's 4 terabytes. 4 terabytes is the limit on Azure SQL, 4 terabytes. This is a huge database. So, the point is, before deciding to pay for something way more expensive, you need to think about app modernization. Why you have a database that is consuming 4 terabytes of size. Why do you have this? Should it be a data warehouse and not a the production database? If this should be a data warehouse, you should be consider other solutions. There are other solutions for data warehouse, like Microsoft Fabric, Synapse Analytics, and so on. So you should consider that. Should it have a deletion policy moving old records to other storage? Uh, is a terrible practice, and this is part of the theory of data management, to keep historical data together production data. Is a fact that every production has a window of valid data, and that's the window of time that the data needs to be on the production database. For example, 6 months, 1 year. What's the window of time that the data really needs to be inside your production database? And why is your data beyond this limit of size? Probably because some manager, some director said, no, I want to keep this data to retrieve reports from this data. Yeah, sure, but then it's not for production, it's for analytics. You should remove from production and move to an analytics solution. Don't keep that in production. When you are on premise, many people don't care. You are just paying some more storage. When you are on the cloud, the cost become way more expensive if you decide to put way more than 4 terabytes inside the data production database. So you need to put some thoughts about why your database is so big. Another kind of data that makes database be extremely big are audit and log records. Many applications make a very detailed audit and very detailed log records, and this is great. This is great for the application. But this is not the kind of data which should be in a relational database and taking space inside your production relational database. This kind of data, when moving to the cloud, could be stored in other places. Azure has a feature called Log Analytics to store this kind of data. You could use Azure Storage. There are other solutions to store this kind of data. You should not store inside the relational database. So these 2 points, historical data, which is there only to be used for analytical purpose, and auditing logs data, they are the 2 points that probably make your database to be huge, your on-premise database to be huge. And you should take care of this before moving to the cloud. And the point, what's better? Is it better to re-architect in your application to solve these problems about data in production which should not be there? Or storing a huge amount of data in a solution that will cost a lot of money from your company? That's the point. And this is the first step in considerations related to app modernization. I was just talking about this slide is a bit of repeating. What makes your database big? Historical data. Historical data should be in analysis solution using Synapse, Fabric, and it should be purged outside the production window. Every production has a window of time, and outside this window of time, the data should be purged from production. And operations log, which grows very fast, are huge, and it should be in another place and not in your production relational database. Another place like Log Analytics on Azure or storage accounts on Azure. One very important point, which I already mentioned before, unless you choose the option to use an hyperscale SQL database, the maximum storage amount for a SQL database is 4 terabytes. You can only go beyond and way beyond 4 terabytes if you use a database called hyperscale, a SQL implementation called hyperscale. I barely agree that hyperscale should be called SQL because the way hyperscale is different of everything we know about SQL is absolutely huge. Hyperscale is completely different about in relation to everything we know about SQL. So, hyperscale architecture. Here you have a link for a video which explains the hyperscale architecture. So you can go to this video, and around 40 minutes of video, the video has a lot of other information. It was for a huge conference. But around the 40 minutes of video, a guy get on the stage and you slowly start explaining the idea of the hyperscale architecture. I was in person at this conference. It was a surprise for everyone. No one was expecting this announcement on that conference. So, if you want to understand deeply what the hyperscale is, you can take a look on this video. Serverless. We talked about DTUs and vCores, but we have another option. We have an option called serverless. SQL serverless, what it means? SQL needs to have a server. What it means to have a SQL serverless? It means that will be charged by the uptime consumption, the consumption that we have related to the the uptime of SQL. This option is only available for vCore. So this means that when you choose the option of implementing a serverless database, you need to be very careful. You need to be very careful because if the amount of usage of your serverless database is considerable, then you'll be paying more than if you choose a DTO solution, because the vCore solution is more expensive than the DTO solution. But if you know that your serverless database will be mostly unused and only eventually will receive some queries, then you can go for a serverless database and you'll be saving even the $5 of a DTU solution. The serverless has a minimum of 1 hour of uptime before going down. What this means? This means that when you send a query to the serverless wakes up and will keep waking up for 1 hour. Is the minimum amount of time it will be up and running, and you'll be charged for 1 hour of usage of the serverless. So the serverless has a minimum of 1 hour of uptime. The first connection is slower. This can result as some applications may receive connection errors when connecting to the serverless. It's just a matter of repeating the connection. Try to connect again, and the serverless will be there. And you need to take care of unexpected calls. Sometimes you provision a serverless, but you make some configuration which generate unexpected calls to your serverless. So your serverless database ends up being up and running way longer than you expect. Example, Microsoft Azure has a service, SQL Defender for SQL, which you can enable for each database to protect the database. But the Defender for SQL will eventually query the database from time to time. And every time the Defender for SQL query a serverless database, the serverless gets up and running for at least 1 hour. And then, if you have this hidden configuration, you end up spending a lot more than you are expecting. And another interesting detail is how serverless allows record scalability. Because on the serverless, you don't choose the number of records we have. We choose the minimum and maximum number of records. So the serverless, according the volume of requests it's receiving, it can scale up to the maximum number of records that you chose. And you'll be only charged by the number of records which are being actually used. So the serverless is an option to make a scalability of the number of records on your Azure SQL database. So here you see an example. The blue line is the configuration of the minimum records for the serverless database. Minimum records is 1. The yellow line is the configuration of the maximum records for the database. The maximum records is 4. Then you have the orange line with the number of records used at every moment, and the green line showing how much you are being billed, how much you receive on the billing. So check the green line, how the green line adapts to the amount of records being used. You configure the serverless to work between 1 and 4 records. Then you'll be charged by the amount of records which are really being used. Then note that at 10 p.m., the serverless stopped to being used. But between 10 p.m. and 11 p.m., you will still be charged by the minimum number of records because the minimum amount of time for the serverless is 1 hour. The serverless needs 1 hour of inactivity to go down. So after 1 hour of inactivity, the serverless goes down. It's like if the database is paused. In this case, you are not being built. See, no green line. You are not being built by anything when the serverless is down. But when a query activates the serverless again, you will start being built again, according the minimum number of records, even if the minimum number of records is not being totally used, but you'll be always be billed by the minimum number of records. Okay, let's see how this impacts. I talked too much. So let's see how this impacts. We are talking about an Azure SQL database. Create an Azure SQL database. So, here on the Azure SQL database, on the provisioning of the Azure SQL database, I have the option compute and storage. This is the option that I'm talking about. We decide how much of compute and storage and we would like to use. And as I said before, a lot of people may be using this feature without knowing that the vCore is more expensive than the DTUs. Okay, someone asked about the link, and there is the link of the YouTube. Thank you very much. Okay, so let me configure the database. Go and configure the database, and here we see the options I talked about. I talked about DTUs. DTUs go on basic, standard, and premium. And the vCore option goes on general purpose, business critical, or hyperscale. As I said, this is an option for Microsoft to put hyperscale as a vCore option. Although, in my opinion, hyperscale is something different. It's a different SQL implementation. You should check that video to see how hyperscale is a different SQL implementation. So, the smallest vCore option, general purpose of 1 gigabyte of size, 2 vCores. The smallest implementation of the vCore costs $226.85. This is the smallest implementation of the vCore. But what if I choose the DTU? Let's go to the DTU, the basic DTU, and I mentioned that the basic DTU always implement 5 DTU. And I have the option to choose the size of the database, which can go to a maximum of 2 gigabytes. And this is the minimum implementation of the DTU, which goes to less than $4. For less than $5, $4.90. See the difference? See the difference? If your company is using vCore on your SQL database by accident because the vCore is the default option, change it. Change it now. You may not need the vCore option. You start always with the DTU option, and then later, according to your usage, you decide or to increase inside the DTU option, the standard and the premium, or to increase inside the DTU option, or to go to the vCore option. The vCore option gives a better control on the amount of vCores you will be using on your SQL database. You can even choose the hardware where this database will be stored, the kind of hardware which will be storing this database. And another option which I mentioned is the serverless option. We have here the serverless option, which I can choose and see the configuration changes. Now I have a minimum number of records and a maximum number of records. So I can choose between a minimum and maximum number of records, and I will always only be charged by the number of records which are actually used. So this will allow my SQL database to scale up and down according its use, and I will only be charged by the amount of records really used. But in my opinion, the best part of the serverless is related to the auto pause, which I can choose should be 1 hour. Unless there was some change, it doesn't accept anything less than 1 hour. The period needs to be 1 hour and 7 days for an auto pause. So the minimum period for the auto pause is 1 hour. So if you have a database which you know which that is not being heavily used, you can choose the vCore option. You can the vCore and the serverless option. So if this database is not being used, it will go down and you'll not be paying for this database. So that's an option to save money. Okay. Now let's talk about single database. That's what I just demonstrated. Possibilities to create a single Azure SQL database between what's called elastic pool. What is an elastic pool? The question is, what if you have a lot of single database? What happens if you have really a lot of single database? Then you need to specify the consumption of this single database, the amount of consumption of this single database. But during many times of the day, this database will not be reaching that total of consumption. So that total of consumption will not be reached. So you are paying the consumption that you choose for the database, and you choose the consumption according to the maximum that the database needs. But many times during the day, the database will not be using that consumption. The database will not be using that. Then we have the option to join a set of multiple databases in what is called an elastic pool. So instead of creating single database, independent single database, we can join a set of database on an elastic pool. What the advantage of this? Take a look on this image. This is showing one database. Check the consumption of this database, DB1. Goes down, up, down, up, down, up. And what happens? You need to pay for 90 DTUs because this is the maximum consumption of this database, but this will be a fixed billing of 90 DTUs. Then what happens if I add more databases, 4 databases in this case? Each database has its own consumption. However, the maximum consumption for the database don't happen at the same time. The maximum consumption for this database happens in different times. At each time, one of the database may be reaching this maximum consumption. So, what's the option? The option is that instead of paying 90 DTUs, the price of 90 DTUs for 4 different databases, you pay 90 DTUs only once, creating an elastic pool and defining the maximum consumption of this elastic pool. So you include many of the single database inside this elastic pool, so this database will make the consumption inside this elastic pool. Will share the consumption time of the elastic pool. And considering that the database have a different time of peak consumption, everything will work. Instead of paying 4 times 90 DTUs, you'll be paying only 1 time 90 DTUs. That's absolutely great. And see how it happens with 20 databases. You can put 20 databases inside an elastic pool and you still be paying something similar. Instead of 90, you can just get an elastic pool of 100 DTUs and you have different peak times for the different database, not going above 100 DTUs. Not going above 100 DTUs. Imagine having to pay 100 DTUs for 20 databases. This would be a huge amount of money. You don't need to. You just put the database inside what is called an elastic pool. The elastic pool, is the first resource, let's say, the first and main resource used in a scenario where you are building software as a service. We are talking about the cloud. You are talking about the cloud. We are talking that you have your database in the cloud and you'll be building a software. To whom you are building this software? Are you building the software to your client? So you may, instead of installing this software in your clients one by one, having the installation of this software on your clients one by one, you would like to create a software as a service. So this 20 database may be a breakdown of your client. You may have one different database in the Azure SQL environment for each client. So in a software as a service environment, you use some resources to break down your client database in multiple databases. And there are development libraries which allow you to manage these multiple databases. Most of the times, the main part of the development library is that there is a main database with metadata. This main database points to where is the data of each client. So when the client logs in, the client is redirected to the correct database. You don't need to develop this manually. Microsoft provides a library for that. Microsoft provides a library for you to develop a software as a service on this scenario. So this is the most common scenario when the application uh, logs in and is redirected to the user database. But what this image is showing is an utility of to make an Elastic database query, a utility called Elastic database query, which allow us to make queries among the many databases. Software as a service is only one of the features to which we can use these tools, these libraries, because this receives another name as well, database sharding. You could be breaking down your database horizontally, putting data in different databases and breaking down the load in different databases. This is called database sharding. And in some situations, you would like to make an Elastic database query, querying data from out the database. Or, in the case of the software as a service, as an administrative task, querying the data on out the database. So these are tools related to the Elastic environment. Elastic database pools, Elastic database tools, Elastic database jobs, Elastic database queries, and features to split or mesh database in the Elastic environment. Sorry that this link is marked as PTBR. It means that it would appear in Portuguese if the link is correct, but you can just choose any US and you find information about the Elastic database tools to be used with Azure SQL. This gives you frameworks and an environment to build your own software as a service. So you'll be building your own software as a service and providing this as a service on the web. There is a difference in relation to the charging of the Elastic pools that I haven't mentioned before, is that the Elastic pools, when you build an Elastic pool, you are not charged about DTUs anymore. Elastic pools are charged about eDTUs. The eDTUs are slightly more expensive than the DTUs. So, according to some experiments that I made a lot of time ago, it only makes sense to create an Elastic pool over 5 databases. If you have less than 5 databases, it doesn't make sense to create an Elastic pool because the eDTU is more expensive, you end up paying more. So you have the database throughput unity and the Elastic database throughput unity. So is the unity to measure the software performance. You can analyze with the DTU calculator. Here is a website related to the DTU calculator, but I think they changed a bit the site. But you can Google it and you'll find the new address if it's not this. So the self-tie is related to DTU databases. Let's talk about the Elastic configuration, see examples about the Elastic configurations. So let me go to SQL database again, create. And again, I'll come to compute and storage. So I can come to DTUs, Sorry, my memory is failing. It's not the correct place to set it as elastic. It's here. Before defining the size of one database, you can choose if you use an elastic pool. Until now, we use a no, but I could choose to yes. See? If I choose to yes, it doesn't ask me anymore the hardware and the safety level of this database, because the database will be included in an elastic pool and will be using this elastic pool. You'll be using the resource defined on this elastic pool. Let me say that I create a new elastic pool. My elastic pool. Okay. Then the compute and storage, which I will define, is for the elastic pool. I will define the compute and the storage for the elastic pool. And again, I can choose the vCore model for the elastic pool, or I can choose the DTU model for the elastic pool. It's a choice. Let's say that I choose the DTU model. Then I can specify how many DTUs this elastic pool will be using. 100 DTUs, 200 DTUs, how many DTUs this elastic pool will be using. This is the maximum number of DTUs, but we will be charged by the amount of DTUs that are really used at every moment on the elastic pool, by the actually used amount of DTUs. And besides that, I can also make a definition for each database. For each database, I can specify a maximum number of DTUs that database can take. For example, if I specify that my elastic pool has 100 of eDTUs, I can specify that each database can take up to 50 eDTUs, 50 DTUs. In this way, at least two databases may be capable to reach their peak time at the same time. If I leave the maximum per database as the same of the maximum of the elastic pool, I have the risk that more than one database reach its peak time at the same time, and the elastic pool will not be capable to support that. So this is an example, is a specification for the elastic pool. So in this case, we can create database inside this elastic pool. And inside the elastic pool is specified for the database. Okay. Then let's talk about a bit about security. When we talk about database in the cloud, there is a huge concern about security. Oh, my database will be public. Your database will only be public if you want your database to be public. Supposing that you really need your database to have a public endpoint, your database has two levels of firewalls. There is a database level firewalls, the firewalls on the database level, and there is the server level firewalls, the firewalls on the server level. So these are two levels of firewalls. and how they work. Uh, First, the database can be completely private. I'll mention that in a moment. Then the way to connect to the database is completely different. Then there is a set of rules related to virtual networks. You can create virtual networks on Azure and define that some virtual networks can connect to your database. This is the first level, which is checked. Then the database level firewall is checked first. First, the user is checked on the database level firewall if the user can access this database. Only later, the user is checked on the server level firewall. An error that everyone does. Everyone does. Everyone is used to open the firewall on the server level firewall. Is an excessive level of permission, is more permission than most applications and most users needed. Most users would need only the permission open on the database level firewall. But why most people end up open the permission on the server level firewall? Because the server level firewall is on the UI. You can see on the UI of the SQL Server that you provisioned the server level firewalls, but the database level firewalls don't appear on the UI. They can only be accessible through store procedures and system tables. So most people ignore that there are two levels of firewall in an Azure SQL. And this is only to mention if your Azure SQL really requires a public access, because you can completely deny the public access for it. I'll talk about this. Another point is the authentication. There are two methods of authentication. You can give permission for the users on the server level, create a login, and then create the database user as we are used on on-premise SQL servers. Or you can create logins directly in the database level, a feature which is called container database. All the Azure SQL database, they are container database. They can receive users created directly in the database. And in this case, the user who have access only to that database and nothing else. And it supports Azure authentication. This means that you don't need to keep creating SQL users. You can create the account of your users on Azure Active Directory, which is now called Azure Entra, Azure Entra IDs. You can create your user accounts on Azure Active Directory and give permission to these accounts on the Azure SQL. And I said before, you can completely block the public access of your SQL database. That's most likely to be done. Imagine on your on-premise database, on your on-premise database environment, do you create a port for anyone on the web to access your on-premise database environment? No, you don't. So why would you do this with a database in the cloud? You don't need to. You just block any public connection. But you need to make additional configuration, and you need to understand about networking to make additional configurations, because you need to configure a virtual network, a virtual subnet, and create what is called a private endpoint inside this environment. Then your applications migrated to the cloud will access your Azure SQL database through the private endpoint. And your Azure SQL database will deny access to anyone outside this environment, outside this private environment, which completely belongs to your company. So you have no need to leave your SQL database open to the public. More reference. The first one is about network and security. It's more about how to configure this last part and configure the network and security for an Azure SQL. The second one is a list of videos about administration on the cloud, how to manage an Azure SQL in the cloud, which has many differences in relation to manage an Azure SQL on-premise. The third one is focus on a bit on development, but on the security of the application. How an application, a developed application in the cloud, will safely access your Azure SQL database in the cloud. So, three different sets of videos that you may would like to watch. Okay, let's see some examples related to Azure SQL Database. Where is it? I have here an Azure SQL Database. This is the database. We are billed according to the database. But every time we create a database, a server is created. Some configurations will always be on server level. So I can open this server in another window. And here I'm seeing server level configurations. Many configurations are server level configurations. For example, server level configurations. The firewall with specified IPs or specified networks which have access to this server. These are server level configurations. Let me drop this. I'll give an interesting example by dropping this. And I have the, sorry, I need to save. And I have here Microsoft Entra ID. I need to specify the administrator of this database. I said that I can make the authentication using Entra ID. Yes, I can. I can make the authentication using Azure Active Directory IDs. But the first step to make this kind of authentication is to have an administrator which belongs to Azure Active Directory. I have a group, and this is the best way to do it, to have a group like SQL admins to manage your SQL Server. And mind that we even have an option to support only Entra authentication for this server. If we enable this option, we will not support regular SQL users. We will only support Azure AD users, it means Entra users, to connect to the server. Okay, that's it. Let me open SQL Server Management Studio. So how do I know the address of this database? Let's go, I can go to the database and connect to the server level. Then I specify Azure Active Directory Universal with MFA. Okay, connect. So I need to remind my password. Let's see. Okay, it's correct. But many of you may have seen this window before. Many of you may have seen this window before. This window is a huge mistake. What I mean, this window is a mistake. I mean, if you follow the instructions of your this window, you are accepting many mistakes on your Azure SQL. For example, this window is asking you, oh, there is no firewall rule to accept your machine on this server. Would you like me to create a firewall rule to accept this machine on the server? I can sign in with my Azure account and accept it and create a firewall rule. It will create a firewall rule, but it will create on the server level. Remind that I said that there are two firewall levels. There is the database level. I could create the rule on a lower level, on the database level. So uh, just following this window without any care, I already create this first mistake. The second mistake is that this window is telling me that we are accessing this database through the public endpoint. Many times you would like to access the database from the private endpoint. And many times you would like the database to only have a private endpoint. If this window appears, it's because you are using the public endpoint, not the private one. So you may be doing two mistakes already on this. I will log in with my Azure account and accept it to create the firewall rule. Oh, MFA, I need to approve this request. Just a second. That's it. So I'm creating a firewall rule which will accept my machine connecting to this server. And I'm connected to this server using an Azure AD account. I had to first define the Azure administrator. I defined the Azure administrator of the server to allow me to connect to the server using my Azure AD account. Why it immediately accepted my account? Because my account is one of the accounts on the group of the administrators. So that's why it accepted my account. About the firewall, what I did there included an IP on the server level firewall. As I said, we should be more careful. We should be more careful than this. Okay, so we saw this example related to Azure SQL Database. And then let's mention managed instance. How the managed instance are different. They allow us to access an entire instance. So we use managed instance when our applications require to access the entire instance of the SQL Server. For example, cross-database queries, to use SQL agent jobs, and other features on server level. Then you need a managed instance. Or you transform your application, or you use managed instance. There are some limitations, but these limitations change every day. And this slide is quite old. So many of the limitations of managed instance may not be present anymore. There are two SQs, general purpose and business critical, charged by the number of records in the storage, and they are created inside a virtual subnet. When we provision a managed instance on Azure environment, it's already entirely provisioned in a secure way. A virtual network is created to that managed instance, and that managed instance is closed inside that virtual network. We only open it outside that virtual network if we want. So it's safe by default. And the access. The managed instance is created inside the virtual subnet. You can create a public endpoint and add an inbound rule to one specific port. Another option is to create a virtual network gateway. I'll not go into many details about the network part, but here you have another link related to managed instance configuration. And another one. Okay, and this is the design. When we talk about managed instance, we are talking about a managed instance VNet and one subnet dedicated to the managed instance. Then your apps can be created in other subnets accessing this managed instance, either from inside your subnet environment or from outside your subnet environment in many different ways, from different VNets and so on. So the managed instance, when provisioned, is provisioned in an extremely safe way, already using virtual networks in the Azure environment. So that's it. We saw a summary of our SQL options. Let me put here on the screen then later, and you have my contacts. It will be a pleasure to stay in touch. I hope you liked this summary, and I went in details, and I hope that you discovered many secrets that you haven't seen before in relation to the usage of these resources, because it's very common that people start using the Azure SQL resources without knowing the best way to choose the resource to use. So thank you very much for attending this session.
Thank you so much, Dennis. The things that I can mention here for those who wants to basically prepare for the exam like AZ900 or Azure SQL Administration, it's the best way because basically you mentioned to every single important things that they need to be prepared for the exam. So thank you so much for all of those information. And yeah, if there is any questions, please let us know. And then Dennis is here to answer those questions. And also, as I've mentioned before, best question will receive a voucher of 50% discount for fundamental exam of Microsoft. So please let us know.
Thank you, Neji. Glad that you liked the session.
Yeah, thank you. Thank you. Perfect. So if there is no any more questions, we can wrap up this session. And thanks again, Dennis. And yeah, hope to see you all in the next week. Basically, I can share the next week calendar. And yeah, that's all. Thank you so much, everyone.
Thank you, everyone.